Assalamu alaikum class. We are going to continue the remaining part of chapter 2 dot product, and we will discuss some questions related to the dot product. So here we have question number 12. Find the angles which the vector A is making with the coordinate axis. So basically we are required to find out the angles that this vector A is making with x axis, y axis and z axis respectively. So let's suppose alpha, beta and gamma be the angles which A is making with positive x, y and z axis respectively. We have previously discussed at how we can find out the angle between any two vectors. So if you remember that if angle theta is the angle between the two vectors A and B, then we can find out the angle theta by using the dot product, because we know that the dot product is defined as A dot B is equal to the magnitude of A into magnitude of B into cos of theta. So we will find out the dot product by using the fact that we can find out the dot product by multiplying the corresponding component and then adding the results. We can find out the magnitude of A and magnitude of B, and then obviously we are able to find out the cos of theta if we are given with the components of A and B. So now on the same basis, if we have to find out the angle between the vector A and x-axis, at first we have to find out some vector along x-axis, and we know the basic vector or the rectangular vector about x-axis is the unit vector I. So it means that we have to find out the angle between this vector A and a unit vector I. So we will apply the same concept, that we will take the dot product of this vector I with the unit vector with this vector A with the unit vector I, so that we know that A dot I will be equal to the magnitude of A into magnitude of I, that is 1 into cos of alpha, because alpha is the angle between the unit vector I and the vector A. So A dot I is simply the product of A with the I. So here you can see I dot I will be 1, I dot j, I dot k will be 0, so only answer is left with 3. Or you can apply the concept that we can multiply it component wise. So the components of A are 3 minus 6 and 2, so 3 minus 6 and 2, and if we represent the components of the unit vector I, it will be 1 0 0. Clearly 3 into 1, the other components will be 0, so 3 will be the answer for A dot I. So now we are able to find out the A dot I. We will find out the magnitude of A, which is 7. So it means that A dot I is equal to magnitude of A into 1 into cos of alpha gives 3 is equal to 7 cos alpha. So we will divide 7 over here, that is cos alpha is equal to 3 by 7, and by taking the cos inverse we can find out the value of alpha. Similarly, for the angle between the vector A and y axis, we have to take the dot product with j, unit vector j, and here is the value of cos beta, and A dot j will be minus 6. And for the angle gamma which the vector A is making with the z axis, we will take the dot product with the unit vector k, and A dot k will be equal to 2. So here 2 by 7 will be the value for cos of gamma. So if you are required to find out the angles that the given vector is making with the coordinate axis, we have to take the cos inverse, and then we will find out the value of the angle alpha, beta and gamma. But if you are required to find out the direction cosine, as we have done in the previous chapter, then you just need to find out the value of cos alpha, cos beta and cos gamma. So you can attempt the question for the direction cosines by any of the methods, either we have discussed in chapter 1 or this one. So this is another way to find out the direction cosines of any given vector. Here we have question number 13. Find the projection of the vector A on the vector B. So as we have discussed in the previous one, that we can find out the projection of any vector about some given vector. For this we just need to take the dot product with the unit vector. So here you can see that if this is a vector A, we have discussed in the previous video that if vector A and vector B are given and angle is theta is the angle between them, then for finding out the projection of this vector A, we just need to take the dot product of this vector A with the unit vector B. So here we have A into unit vector B, but before we need to find out the unit vector B, and for unit vector we have to divide the vector with its magnitude. So the magnitude of B is 9, and here we have find out the unit vector, and for projection of A on B we will find out A dot B, and here is the answer 19 by 9. Question number 14 is not included right now. Question number 15 is your homework, and you have to check it out. Next we have question number 16. Determine a unit vector perpendicular to the plane of A and B. So we are required to find out a unit vector which is perpendicular to the plane of A and B. Before solving this question, just understand this, that let's suppose if this is the coordinate system x, y and z, this is x-axis, y-axis and z-axis. So if this is x-axis and y-axis, then it means this one is representing the xy plane and the z-axis is perpendicular to this plane, or the unit vector along z-axis will be perpendicular to this plane. So if we are saying that, and obviously if the unit vector k is perpendicular to the xy plane, it means it is perpendicular to the unit vector I as well as the unit vector j. So this is the basic concept behind this, that if you have to find out the unit vector perpendicular to the plane of A and B, it means we have to find out a unit vector which is perpendicular to both A and B. So here you can also see that this is the plane that A and B are making, and the vector C is perpendicular to the plane, means the vector C is perpendicular to A and B. So if the vector C is perpendicular to both A and B, it means its dot product with the two vectors must be 0. So we will use this condition to find out the vector C. So let's suppose the vector C is C1 I cap, C2 j cap and C3 k cap, and by using the condition that it is perpendicular to both A and B, we will try to find out the values of C1, C2 and C3. And since it is perpendicular to the plane, so it is perpendicular to both vectors, that is C dot A must be 0 and C dot B must be 0. So here we have evaluated C dot A and C dot B. So here is the vector A, where is the vector C. So 2 into C1, then we will multiply the y components, that is minus 6 C2 minus 3 C3, and C dot B is given. So the both terms must be equal to 0. Now we will solve these two equations. We are not able to find out C1, C2, C3 separately because we are having two equations and three unknowns. So we have to determine the variables in terms of the parametric equations or the parametric form. So at first, here is the value of 3 times of C3. Here is C3. We can eliminate C1 easily. So here you can see that C2 is equal to minus 1 by 3 into C3. Now inserting this value of C2 in equation 1 or 2, we can easily find out the value of C1, which is also in terms of C3. So here we have evaluated C1 and C2 in terms of C3. So inserting the value in the vector C, we get C3 is equal to 1 by 2 minus 1 by 3 j cap plus k cap. Now we have to find out the unit vector, and we know that to find out the unit vector, we just need to divide the vector by its magnitude. So at first we will find out the magnitude of this vector. So the magnitude of vector C is this one. Here we have evaluated this, which is basically 6 by 7 C3. So here we have cancelled out the C3 with each other, and here is the final answer of this unit vector, which is perpendicular to the both given vectors. Next we have question number 17. Find the work done in moving an object along a vector r if the applied force is F. So we know that the work done is defined as F dot r. So here we just need to take the dot product of the two vectors, and we will find out the work done for this. Next we have question number 18. We have to find out an equation for the plane perpendicular to the vector A and passing through the terminal point of the vector B. So it means that we have to find out the equation of this plane which is passing through the terminal point of this vector B. So here is the Q is the terminal point of this vector B, and this vector A is perpendicular to the whole plane. So this is the required term, that we are given with the vector A which is perpendicular to the plane, and we are given with the vector B, and the plane is passing through the terminal point of this vector. So it means that if the plane is passing through this point, so this point is lying on the plane. So what we are going to do, we are just taking an arbitrary point on the plane P, X, Y, and we will join this point P with the point Q. And obviously if the point P and Q both are on this plane, then this vector PQ will also lie on the same plane. So here we will able to define a head to tail rule over here, that is the vector R plus vector PQ is equal to the vector B, that is the vector PQ is equal equal to b minus r. So here we have the vector pq is equal to b minus r. Now we know that, or we are given with the condition that the vector a is perpendicular to the whole plane. It means it must be perpendicular to the vector pq. So if a is perpendicular to the vector pq, then their dot product must be 0. That is, a dot pq is equal to 0, or a dot b minus r must be equal to 0. So here we have applied the distributive law that r dot a is equal to b dot a, which is basically the required form of this one. And we can find out it further. R dot a, because r is the point, or r is the vector with the components x, y and z, so we can take the dot product of r with a as 2x plus 3y plus 6c, and here is the dot product with b, so here is 35. So if you do not want to apply the distributive law over here, you can solve this equation as well, and you will get the same answer. And obviously b minus r is going to be the difference of the two vectors, and the vector b is given to us, and vector r is basically x, y and z, that is xi cap plus yj cap plus zk cap. So b minus r will be equal to 1 minus x 1 minus x I component, then 5 minus yj component, and then 3 minus k component, and 3 minus zk component. Then we have to apply the dot product with a, and it must be 0. So the dot product with a is going to be 2 into 1 minus x plus 3 into 5 minus y plus 6 into 3 minus z is equal to 0. So when you solve this, you will get the same equation, 2x plus 3y plus 6z is equal to 35, which is the required equation. Next we have question number 19. In problem 18, find the distance from the origin to the plane. So we are given with a vector a which is perpendicular to the plane, and the vector b and the plane p is passing the terminal point of this vector b, and we have to find out the distance of the plane and the origin. So clearly the distance is always measured with the help of a perpendicular length. So it means that what we are supposed to do, we have to find out this length. We have to find out the perpendicular length, which is going to define the distance of the point from the origin. And because if we draw the perpendicular length over here, or we will find out the projection of this point b on this vector a, and the vector is perpendicular, so this is going to be the perpendicular distance, or the finite distance of this plane from the origin. So we will find out the dot product of b with the unit vector a. So here we have find out the dot product of b with the unit vector a, and before this obviously we have find out the unit vector a by dividing the a with its magnitude, and the answer is 5. So the distance of the plane from origin is 5 units. Here we have question number 20. If a is any vector, then prove that a is equal to a dot I unit vector I plus a dot j unit vector j plus a dot k unit vector k. Clearly a dot I will be equal to a1, a dot j will be a2, and a dot k will be a3. So we can replace a1, a2 and a3 by these terms.